Welcome to this video. We will practice using sentiment analysis with the earning calls dataset. As you remember, this dataset contains 10 earning calls, including the full text of each one of the earning calls. We have two questions here. One of them is to select the most positive sentence and the most negative sentence in each one of the earning calls. The second question is to incorporate the subjectivity and select more objectively expressed sentiments, meaning low subjectivity in these texts. We're going to use text blob, and we're going to use the same strategy that we used before. We're going to process one of these earning calls, and then we're going to put all of the steps in processing this text in a function that we can then apply on all of the earning calls. So I'm going first to extract one of the earning calls. So let's call this one text, and let's get the first earning call, and text is the second column, so we need to be iloc01 to get that text. Once again, this is a large piece of text, and we probably don't want to print the whole text. And one of the values of doing sentiment analysis and many of the text processing techniques is that we don't have the time to read all of the text of all of the earning calls. So we just want to do a very focused analysis of what this text is about, and sentiment analysis is one way in which we can probe the sentiment of the executives of these companies to see what is the most exciting things in the earning calls, or what are the kind of main concerning issues for their companies. The next step is to create our blob object. The blob object can be created by passing text to the constructor of text blob. We're going to break this text by sentences. So we're going to access the sentences attribute, which basically give us each sentence in the earning call. So if we pull a random sentence, for instance, sentence 33, that's a sentence, right? Now we want to get the sentiment for each sentence, so we can use the attribute sentiment. Don't forget that this is a sentence object, so we can get its sentiment. And this one, it did not detect any sentiment, so polarity was 0 and subjectivity was 0, which is probably okay here. I mean, this sentence doesn't express any sentiment, so to speak. It's just stating some facts. Okay, so that's the sentiment, but then we want to get the polarity, at least for the first question. So we can get 0 here, and that will basically give us the polarity of the sentence. Now in each one of these sentences, we want to get the polarity of the sentence. So there are a couple of ways to do this. We can either use pandas or Python here. What I'm going to do, I'm going to create the dictionary that maps each sentence to its sentiment. So let's do that. Now, don't forget that this is a sentence object, and we can get the text of that sentence if we wish. It's actually an attribute called raw here. What I'm going to do here, I'm going to get each sentence and map the raw text of the sentence to its sentiment polarity. So I'm going to put sentence, sentiment, and 0. Now what is sentence? It basically goes over each sentence in text.sentences. That's a dictionary comprehension, so I'm creating a new dictionary that maps each text to its polarity for each sentence in text.sentences. It's actually the blob, not the text. The text itself is a string object, the blob object itself. So that's my dictionary. So let's call this one polarity here. and that is my dictionary. Now the next step is to select the sentence that has the higher value of sentiment polarity here. And there are multiple ways of doing it. We can either use Python, we can sort, or we can use a function max, or we can create a pandas series out of this. So if we create a series from polarities here, we will get a series that has the index being the sentence and the value being the polarity. And then we can sort values. And I can do ascending is equal to false here, right? So that's the most positive sentence here. Now we can get the index of that series and get the first value if you want the most positive one. Another way to do it is to create the series and take the maximum value. Now the maximum value will be a value, so then we need to mask the series to get the index. There is another function called idx max, which stands for the index of the maximum value. And this is pretty handy because it gives us the index of the maximum value in the series. Now this is interesting because we see that each one of these two ways of getting to the answer is giving us a different answer. And this is probably because this is giving us, both of them have the same polarity, which happens to be 0.8 in this example here. Now notice that idx max will give us one of these, which is not guaranteed to be the value that is on the top when we sort it out. And this is probably why we may need to return a couple of sentences, maybe the first 5 or 10 most positive sentences, if we want to get a better idea of, what drives the text to be positive. For the sake of simplicity, I'm going to look only at one of these sentences. So what I'm going to do here, I'm going to return, or basically that's the result, most positive here. Positive is the idx max of the sentence. Now once we do this, we can isolate this in a function. So I'm going to call this function most positive sentence in this piece of text. Obviously this one is no longer needed, and I'm going to return most positive here. Now I can test my function on the first one, and I already know the result. I can test it on the second one, and that should be the most positive sentence in the second one. Let's take a look at the third one. So that's the most positive sentence in the third earning call. And you can see that it's starting to get us some idea of what is exciting the executive of these companies. That's the last one, or the one prior to the last one. This one is the last one. Okay, so now we want to process all of them. So what I'm going to do, I'm going to apply this function on the text from my data frame. Let's call this one most positive sentence, or most positive, and apply most positive here. Okay, so now this will apply it on each one of the texts in the series, in the data frame. So you can see the most positive sentence in each one of these earning calls. Now it's also asking us for the most negative sentence, and the only thing we need to change here is to change idx max to be idx min, and this will give us the most negative sentence. So we can create another function called most negative if we wish, or we can make a function that either give us the most positive or the most negative. So let's call this function most polarized sentence, and let's have a parameter called direction is positive, and it can be negative. And what I'm going to do here, I'm going to have an if statement. Let's call this one most polarized here. In my if statement, we'll test if direction is equal to positive. Then we can do idx max, else we can do idx min. We can also make sure that it's negative, else if in Python, else if direction is negative. And have a final kind of catch all, else it's going to make it none, just to make sure if somebody passes something which is not positive or negative, or not returning something by default. Alright, so here is the new function here, and by default it does the most positive. The direction is positive, so when I do this apply here, nothing needs to change. It will do the positive. How about the most negative here? Now the problem here is that I want to pass the parameter to direction to be negative, which means I need to call this function. So I'm going to need another helper function here, a lambda expression, and x will be each one of the text. So x is basically text. I can call it text actually here to be even more expressive. So for each one of these text, I'm going to call most polarized text, but I'm going to set my direction to be negative. So that basically will call it for the most negative and the most positive, for the most negative rather than the most positive, I meant to say. So now if we scroll here, we can see the most negative sentence. Let's take a look at most negative here. And obviously pandas is shortening these sentences, so I'm going to convert it to a list to read the whole thing. So you can see that they're not as meaningful as the positive one. So the most negative sentence is I'm sorry, which is kind of an interjective sentence, doesn't carry any special meaning. Same here, right? So some of them are okay. So for instance, when somebody's talking about depreciation and decrease in revenue or expenses, that's okay kind of, but some of these sentences, such as I'm sorry, are not very meaningful. And hence this is why we probably need to incorporate the subjectivity. Maybe we want to look at more objective sentiment, and that will probably take care of some of the most objective ones, such as I'm sorry. No, it's difficult to say. So let's go back to one of the texts here. Let's go back to the first one. Actually, I'm going to copy this text here. Data.ilog01, and let's create the blob object. This sentence has a slightly negative. Oops. Let's take a look at one random sentence. Let's examine the sentiment of this sentence, and you can see it has a slightly negative sentence, and it's also subjective because it says that, well, I think that this is the case, right? So there's an element of subjectivity into it. So I think what makes sense in this case is to probably multiply the polarity of the sentence by its subjectivity, or the inverse subjectivity, which is objectivity, to minimize the polarity of the sentence, given that it's very, very subjective. So what we can do here, we can get to sentiment. Let's call this one sentiment. And we can multiply sentiment polarity, which is the first, excuse me, let's get sentiment, the polarity of the sentence. We can multiply it by its subjectivity. Actually, we want to multiply it by the inverse of its subjectivity, because we want to look at objective sentences. So I'm going to make it the opposite. Subjectivity varies from 0 to 1. So 1 minus subjectivity is kind of a measure of objectivity. And you can see that this kind of minimizes the polarity of the sentence because I'm weighing it by its objectivity. So what I'm going to do now, I'm going to do the same here, and I'm going, actually, there are two options here. Either I copy paste the function and change it, or what I can do, I can make this function more versatile. What I'm going to do, I'm going to have another parameter. Let's call it objectivity. By default, it's going to be false. If this parameter is true, then I need to get the sentiment weighed down by its objectivity. So let's take a look here at how we can do that. The element of doing it is here when we construct the dictionary. Because if objectivity is false, we don't want to do anything. If objectivity is true, we need to change how we associate this. So if objectivity is true, we want to weigh this one by sentiment 1. What I'm going to do here, I'm going to include a conditional expression. So I'm going to say sentence.sentiment 0 if not objectivity, else sentiment 0 times sentence dot sentiment 1, that's the same conversion that I have done, minus sentence dot sentiment 1. Or vice versa. If I don't want to say if not objectivity, I can say if objectivity and flip this one, the if part with the else part. It's basically a conditional expression. Let's have kind of a look here. So let's say condition is true. So let's say, for instance, 1 if condition, else 2, that will be 1. If condition is false, 1 if condition else 2 is going to be 2, right? So this expression will evaluate to either this part, the if part, or the else part, depending on condition. That's basically what I'm doing here. I'm saying sentence.sentiment 0 if not objectivity, because by default it's going to be false. Otherwise, sentiment 0, which is the polarity times 1 minus sentiment 1, which give us the objectivity. So that's the new function. And because I made the default parameter to be false, even if I rerun the code, nothing will change here. That's basically the same, will give us the same results. Nothing will change here. However, now I can call this function, and I'm going to call this one most positive objective. Now I need to provide parameters to my function. So here I need a lambda expression for positive, and I'm going to make a lambda expression. Direction is positive, and objective is going to be objectivity, going to be true here in this case. And I'm going to do the same thing for the most negative objective. This one is going to be negative here. Alright, so now let's take a look at what we have here. I'm going to look at the most positive, that's the most positive. And then I'm going to look at the most positive objective. You notice that the second sentence here is very subjective. It has an opinion. And this will give us a slightly different result here. We can take a look at the most negative. That's the most negative ones. And we can take a look at the most negative objective of these. And you can see that many of the subjective things that I am sorry or things like that have disappeared, right? So we're kind of getting more into factual statements that convey a negative sentiment. Once again, we go through this list, and some of them still don't make sense. Again, it's not a silver bullet, and it's making mistakes. It's not the best sentiment analyzer out in the world, and probably it makes sense to look at, top 5, top 10 negative or positive sentences in each one of the earning calls if we're going to have kind of a more better understanding of what is triggering these sentiments. Nonetheless, you can see that it's still giving us some meaningful condensed information and giving us an idea about these earning calls